Thank you for granting us this interview. Can you please introduce yourself and let us know a little bit about your background and the work you're currently involved in?
I'm Andrew Lowe. I'm one of the STSMs, which is a senior technical staff member on the IBM JDK team. My expertise is in Java virtual machines. I've been doing virtual machines for more than 16 years now. I'm an expert in Java technology. And what I've been working on lately, well, two main areas really. I've been working on performance, and performance, not just throughput performance, but there's really three pillars of performance. There's throughput, there's startup, or what I call agility, and then footprint is also another metric that's important for performance. So looking at all three and figuring out how to balance those, which if you do achieve, which you can, you end up with really good real-world performance in your applications. The other area I've been working is in virtualization, looking at how we can take Java runtimes and Java workloads and get them to work in the cloud environments.
And what's impressed you in monitoring developments in Java technology?
Well, IBM's been involved with Java from the very beginning, which is really cool. And watch Java develop into something that's effectively the next COBOL. It's a very mature language that has a very broad ecosystem of software out there. And that's actually the one thing that's really impressive, because one of the pieces of technology I worked in the past was developing a Smalltalk virtual machine. And I'm an old Smalltalk guy. And so, Smalltalk came and went, and there's still a small crowd of people who do Smalltalk, but it really didn't make the mainstream like Java did. Java was very successful, I think, because of its syntax and the flexibility that we've been able to do to the language without actually changing any of the real fundamentals. So I think that's where Java's been impressive.
And what's IBM's stake and investment in Java technologies?
Well, I mentioned, IBM's been involved with Java from the very beginning, and we watched it grow and mature. We were very early on working with Sun when they had Java, and IBM's portfolio look across the IBM software, lots of it written in Java now. And so, as a company, we're very dependent on Java. A lot of our customers are in Java as well. And in terms of, our stake in Java, last fall, IBM and Oracle announced a partnership around Java. IBM's taking a more active role in helping guide and develop Java as a language and as a platform for our customers. And so, definitely, we're deeply involved in Java and deeply committed to Java.
What are the technology focus areas for IBM in Java?
I'd say we're definitely working to bring some of the things that are value adds that IBM has in its Java to the base Java that's hosted in the OpenJDK. We're looking at things like some of the language support, some of the other platforms. We've already brought things like ZOS and AIX in terms of what we've done, but we want that to be supported as part of what is in the OpenJDK base. We're looking at things like modularization and guiding the Java 8 plan. We're definitely working hard right now on Java 7 and a delivery there for that version of Java. I'm looking at virtualization. I'm very interested in those things. I'd say that almost every aspect of Java, IBM's got someone involved, either participating in the specifications or just working on delivering a world-class piece of software.
Do you see any challenges with Java scaling up in leveraging multi-core systems?
The primary scaling up problem with multi-core systems is making your application concurrent. If you look at a typical application, you get it to about 4 cores and use those 4 cores pretty well. Once you go back past that level, it gets more difficult. And there's a lot of issues there. Some of the algorithms and data structures being used by the base class library need to change. And we're starting to see some of that in JSR 166 with the concurrency utilities. We need to go further than that as we go along. The JVM itself is starting to make use more and more of helper threads within the runtime to exploit the fact that there are idle cores. But in the end, depending on your approach, you're going to have to take a look at the application and how you can make your data structure start to scale. So I think tooling is an important aspect of making a better thing for our customers, helping them understand where their bottlenecks are and how, providing them with sort of canned solutions, so breaking up certain workloads into different packets so you can do parallel execution. So definitely a lot of challenges around parallel computing and exploiting multi-core. But I think that from a technology base, we have a great base for that. It's just a matter of building on top of that and helping the applications that everybody has out there move on to these new systems.
Now, while Java and the JVM approaches memory management as an internal matter, there are efforts towards moving parts of memory outside JavaHeap. For instance, look at Gigaspaces, Terracotta, and their eCache, etc. What are your thoughts on how this is going to shape up? More specifically, will the garbage collection technology become optimal for specific uses, like caching, for instance?
So there's a couple of different pieces of that question. One is, the current trend where there's some applications or solutions coming forward to say, let's move some of this memory outside of the Java heap and manage it externally. That's a point-in-time solution I see. I think some of those are great solutions for the problem sets they have. And the argument you put forward is saying that, well, I have a very specific problem here. And because it's very specific and I know what the data is, I can do better than a general-purpose garbage collector can. That's true, but as garbage collection technology advances, and it does continue to advance, we're going to start seeing very effective very effective algorithms at GC that manage subspaces and are able to deal with the kind of things that a lot of the algorithms about moving data out of the heap are trying to address. I think that this is one of the reasons that Java as a runtime environment for other languages. We're seeing people build other languages on top of the JVM. They're doing that because Java's got things like garbage collection sorted out. When you start moving things outside of the heap and having to do your own management, that's putting a lot of effort onto the other your framework or you to do garbage collection of that memory you've got outside the heap. And people are going to run into the same problems with garbage collection experts, which we work with here at IBM. They've looked at these problems for a long time, and they've got good solutions. So I think that, yes, there are going to be some very successful companies that have point-in-time solutions for very specific data sets. When we get to broader problems and large data, I think we're going to fall back into garbage collection technology, having the heap managed by the Java runtime. And we're going to do a good job doing that because we are already thinking about some of these things. Not only just, how do I deal with today's data, which is hitting, 4, 5, 6 gigabyte heaps, but looking at 100, 200, 300 gigabyte heaps, and how do I manage that in a way that's going to be effective for what, you're trying to put on top of us in terms of workload and still have good response time.
Lately, there's an appliance-based delivery of Java, Azul. That approach has compelling technical claims, be it pauseless garbage collection or the simplicity in attaining elasticity, Zing. Can you compare and contrast the terms of the overall cost, usability, and scalability of IBM's approach versus the appliance-based approach? Well,
I'm not sure that question actually applies in the sense that IBM is also looking at appliance-based approach. We've got a different take on it than Azul and Zing. But I think the appliance-based approach is a very valid one. And as I said, IBM is definitely exploring that space. We already have products in the appliance space such as Data Power. And so in terms of some of the claims, definitely there's things you can do. I mean, Azul's got a long history of having, sort of the customized hardware and some really great insight into doing, high performance of garbage collection and large heaps and those kind of things. I think it's great. Where IBM differentiates itself from a product like Azul is that we support a lot of different platforms. And it's one of the things that myself and my team do is we work across all of IBM's platforms. So, as a customer looking at a solution, it's great to talk about here's an appliance and I can offload my work over there. But in the end, if you've already bought the hardware and you have free cycles there, why not make use of those? And so I think, along with the appliance trend, we're also going to see things like hybrid systems, where you've got maybe some X systems, Intel-based systems. You'll also have some P systems, power-based systems, and you're mixing them together. And what's going to get really interesting is the fabric between those systems. And I think with appliances, we're going to have to start figuring out how do I get my appliance plugged in to the other systems I've got and get a good fabric between them so that they can start sharing data across them quickly. I guess I've sort of dodged around the question a little bit. I think appliance-based systems are very interesting, and as I said, IBM's definitely investing in that area. So I'm not sure that there's a difference between our approach and others because we want to do both, and I think we have the capacity to do both well.
Any advice for our readers and young developers who are aspiring to pursue a career in Java?
Well, Java is a very safe language to learn, but if I was a young developer out there learning stuff, I'd have, I'd be up to my knees or higher looking at things like some of the web languages. You need to get Ruby, understand some of the concepts of Ruby. You definitely want to have some PHP. Perl hacking is always good. Understanding Linux and some of those things, definitely key to having skills today. JavaScript, I think it's sort of an awful language. It's actually a really interesting environment to work in. You definitely want to have your hands there. So I'd be everywhere. But as a young developer, and even still now, although to a lesser degree, I used to pick up a new programming language every 3 months or so. And that was really out of personal interest. I'd take some time in the evenings and say, okay, what can I do now? And, when you're doing that, don't just learn the language. Take a task on. Say, I'm going to accomplish X. And nowadays, what that X should be is, every young developer should be out there saying, oh yeah, I have a web presence. I got a blog, and yeah, I wrote the software for the blog, and here's my cool extensions, and I'm contributing to these open source projects. Get out there, get involved, get your hands on the code. Chase what you love doing. I'm very fortunate. I have a job where I love doing what I'm doing. It makes it really easy to do a lot of it, and that's what's going to make you successful. Go and do stuff. Don't just learn. Don't just be involved with interesting things. Go and make interesting things yourselves.